Hello, hello. Testing. Almost there.
Morning.
Good morning. Oh, thank you, thank you. I think. Sorry, I know you can't see me yet. Um, wait, I'm confused. Sorry, something is weird. Yes. Okay, so I think. Oh wait, no. Right. Okay. So I think you can see me. I think I can not see you. I think see you, so to speak. Okay. Wait. I can admit.
Yeah, we can see
Okay.
you.
Thank you. Okay. And oh, now this is a class. Now, hello. It's good to see you. Hopefully, you're starting to get back. I know I'm, as usual, I'm slower than you. That's bad and good. But hopefully, you're starting to see the 50-point things coming back to you now, which would just be that as 50 points and with a quick comment like "cool" or "yes, I remember" or "thank you" or whatever. But just starting like the first 50-point things that you submitted last week, hopefully at least seeing now that they are being entered into my system, and we're going to keep doing that. So you've got 2 more portals today open for 50 points. And again, you can use them at any time by sending them back to you in staggered piles. I'm hopefully even showing you that you can submit them in staggered piles, whatever. With your one thing I should let you know, so I had a great catch up with the Walters, both Walters, yesterday. Um, um, they teach physics also. Some of you know some of them, but so we will have an exam is what that, we will have an exam 2 weeks from today. I don't think it should be, well, for some of us, it's very stressful not to know when exams are, and I apologize for that. I don't mean for exams to be very stressful, but we do have them. Of course, there will be one 2 weeks from today. We will start talking about it more this Wednesday and next Monday. But let me say again, if I've never said before, what exam means in this class is first and foremost is that you'll get a practice exam before the exam. Like we may not have it ready exactly this Wednesday, but you'll certainly have it by next Monday, and you'll get solutions. Also, maybe not right away, but before you ever take an exam here, you will get a document that looks very much like the exam. That's like 85% similar, or well, no, it's like 100% similar, and it's like 85% identical, or so, or 75% identical to the actual exam. And you will practice with the practice exam, and you will not be graded on the practice exam. You'll just use it to practice and see what you need to know, blah, blah, blah. And you will, as I said, get solutions to it. So there's every way to not be surprised by the actual exam when it comes, if one wishes. And there's a very sort of easy, straightforward way to prepare, like even if the material is not necessarily easy or straightforward. But we'll talk more about that as we get to it. Plus, it will probably also be take home, to tell you the truth, because of Zoom Life being what it is. But just so you know, we will have, it'll be that midterm will be in 2 weeks. Then we have a final exam, and it's those 2 things together, plus the lab, plus all these, what were homework points and are now becoming participation points. All those together make the grade. All right. As far as the material, you guys are not behind at all. You guys are actually a little bit ahead, because I remember we closed the last class with me actually giving you a 3-vector problem. A part of me is tempted to pick up right from that exact one that you were doing right as we closed down shop last time. And I may want to check those answers that we got, but part of me also would rather right now start fresh. So let's do this together. So those of you who nailed it last time are going to find this maybe a cakewalk, and you'll be very on top of vectors. But here's the problem. It's on the board. Okay. This is just like last time, but now it's 3 vectors. And by the way, this can seem like endless madness. We're not going to then do 4 vectors and then 5 and just slog forever. The big difference between 2 and 3 vectors, the big difference, why we do have to do at least one problem that has 3 vectors in it, is that with 2 vectors, there's ways you can get lucky with 2 vectors being put together. There's ways to see triangle tricks. and laws of cosines and things like that. For almost any one individual two vector problem you give, there's tricks that can work for that particular problem, but then won't work for any other random two vectors. In other words, uh, there's ways to fake your way out of knowing the actual universal technique. But with three vectors, the rubber hits the road. There's just no way to add three vectors. There really is no way to add three vectors other than drawing a really, really good picture and really using the picture correctly, and that is fair, or doing this arithmetic method that we call components that we were trying to do last time, that I think Ardell, a number of people were doing last time. That's what we need to do. Like if you really get that method, it'll work for three vectors, four vectors, whatever. And conversely, if you don't have that method, you can't handle three vectors, four vectors, and it comes up all the time in physics. So actually what we're learning here, weirdly enough, I know we're in college and all that, but honestly, what we're learning is addition. I mean, as strange as this is, like second grade, in that we're literally learning how to add here. And what comes, once you know how to add, then you learn how to subtract. And then what comes on, believe it or not, is multiplication, which is multiplying is hard. Well, I shouldn't say it's hard, but it's a thing that has to be learned for vectors. We are learning how to add now, not numbers. You learned how to add numbers in second grade. And by the way, I don't think it was that easy then. Like it may seem easy now how to add numbers, but it's a pretty abstract, big leap when you learn it the first time. What we're learning now is how to add up quantities in two-dimensional or three-dimensional or higher dimensional space. That's what we're really learning, is how to add in higher dimensional space. And as I said, what comes next is subtraction and multiplication. It's not a joke. It's like something to actually know. And last thing, so here's the problem. The problem is right here on the board, is kind of like last time, but I walk 10 meters due north. Okay, so that now in my mind means, on the page, north is up, south is down the page, east is to the right, west is left, in my mind and in all of our minds, hopefully. And to the right, I make positive, whereas to the left is negative. And independently up, I make positive, and down I make negative. But assuming all that, I walk 10 meters due north. Then imagine that I walk 20 meters at 30 degrees southeast. Okay, southeast. All right. And that 30 degrees southeast means it's just a compass direction in and of itself. And then from there, I walk 30 meters at 60 degrees northeast. Okay, that's the problem of the moment. That's it. Those are the givens. If you're following this so far, you'll already understand that the question is, what is the total displacement? What is the sum of those three vectors? I will shut up. I really will. I'm going to turn it to you guys again. But what you're looking for here, and I'll start drawing things and whatnot just to keep us all occupied. But what you're looking for here is a final vector. You're looking for a size and a direction. The direction will be an angle and will include points of the compass. So what I'm really, really saying here is, no matter how fast or smart or anybody is, like, this number cannot, I don't see how to get the final answer to this just like in one beat in your mind. I mean, I know it, but I don't just see it in my mind. I have to do computations. I have to draw to get this final answer that we're looking for. The final answer will be some number of meters. It'll be some angle, and it'll be some points of the compass, like southeast, northwest, whatever. That's what I'm asking everybody to do right now. Anything I put on the page will be just different ways I have of drawing the question to try to help, but they don't give away an answer. And I'll say, anytime anybody has anything to say, at all, question or whatever, obviously please do, or say it, or say it in the public chat. What happened in the last class, if you feel like you get an answer, I guess it might be good if you actually have a final answer, since this is a thick enough problem, and it really is. Like, yeah, I'm not expecting anybody just to see this right away. It takes some time, but the answer is the answer. It's not like a matter of opinion. So if you think you have a final answer to this, I would say, sure, put in the private chat, right? Especially if you're nervous at all, or if you're think I'm nervous. If you have a final answer, put it in the private chat, and then I'll tell you like what to do, like if I agree or not. But until that time, anybody can publicly say anything to ask or to help this along. But we are looking to add these three vectors. Put another way, this is the problem, just restated. Maybe easier to follow on this page. And when I flip to the third page eventually, it's yet still the problem, just sort of drawn out. Okay, so whatever page is staring in your face, that's the problem we're working on right now. I'm gonna bless you. I bless you all. Ah, okay, wait. Okay. Hold on, I'm just reading. So there's a lot going on in the chat. Oh, sorry. Ah, okay. So, all right, hold on. I think, oh, wait. So a lot's happening in the private chat. Okay. Uh, okay, so this is great. Now a lot's happening in the private chat, partly because what a lot of people are now getting, and I don't mean this to rush other people. This is also strange, but I'm getting a lot of now like answers in the private chat, and so I will even say, and I'm typing to keep up. There's a number of them, and they're different. They are different answers. Some of them are right. I almost shouldn't have said that so fast. Some of them are, I think, not. Of course, it's always possible. I made a mistake, but I think I've checked it a number of times at this point. But what do I want to say? Hold on. And I understand why these things are happening in the private chat because they're like answers. So people also don't want to give it away to others, which is very considerate. So bear with me for a second. I will say what's clear in my mind is anybody who has, let me put it this way. Well, no, I won't. Let me just respond to some of these chats for a second. This is what the private chat freaks me out because it's like, but I do get why people are using it. This would be a right purpose for using it. So hold on a second. Now, one thing what's so wild about all this, like learning this way or whatever, more and more I am seeing how you guys are thinking about this, which is really useful. It really is good, and it does help me manage everybody. But of course, it's all slow. Wait, so I'm seeing, right. One thing I can say about, right. Oh, interesting. Oh, 1 second. Right, this is happening for. See, okay, 1 second. Okay, now. See, one thing, and I'm delaying, like obviously at some point fairly soon, I can walk through this or someone else can. And there's advantages and disadvantages of, like obviously some people I think do have the right answer, but not most people. So I also want to give people time. but I want to say what's interesting about a problem like this is now where we're kind of really getting into science for real or physics for real. Like a problem like this, and I'm not saying it's fascinating. It's not fascinating, but it is, this problem is thick enough and intricate enough that it can't be faked. Like the final answer is a very specific final answer that can't just be guessed in one's head. But what I'm getting at when I say that is all these people that have answers in the private chat, anybody that's giving me any answers at all that, for example, has square roots in it. Like one person said, I think I got square root of blah, but I'm not sure, what that is. So I'm not sure if it's right. And so I checked it and they might've been right. And it would be okay to leave certain things as square roots, but that does show a disadvantage. Like they're harder to relate to, like to write down like the square root of 29 or something. But what I'm really trying to say to everybody is by the time you're asking me in the private chat something about square root of like anything, it's so clear that you're doing something that is on the right track. Like that you are obviously honestly there's no one would just guess a square root unless, I mean, there are square roots related to this. So, but what's so funny is if we just, the problem with focusing on the answers, and I'm not saying there's any better way, but any one of you who's proposed an answer to me, and if I say it's wrong in the private chat, you can't possibly see is how much you must have done right in order to get to that wrong answer, or what I can't even possibly tell you, because in some cases you haven't shown me, like, I literally don't know. Hold on a second. And the people are coming in the waiting room, blah, blah, blah. But there are ways where, yes, and an answer, wait. Oh, no, this is good. Okay, wait, I think someone just, now what I'm starting to get now in the private chat, this is interesting. Okay, and I literally can't even keep up. So I'm going to keep doing this. I'm going to keep talking to you guys about what I'm seeing in the private chat. And I hope I'm not destroying its spirit. Like I'm not going to mention anybody's names, so I'm not connecting. But I hope you don't mind that I'm going to say that, like, so there's like all this stuff happening in the private, all this stuff. I mean, not world events, but there's all this stuff happening in the private chat, and all of it that's happening is really substantive. Like it's a class unto itself. If literally everybody in the private chat were saying what they were saying to everybody else, which they would if we were doing a thing called a board meeting now, which I love to do in regular classes, we really would be sitting and having this talk. But I understand why all these super specific things are in the private chat, because they take so much guts to say and they're so subject to possibly being wrong or whatever. But now at least I'm starting to get in the private chat, I'm starting to get people say things like, hi, I'm still working, but here's where I am. I want to suggest, like I've gotten that a total displacement is this. I haven't gotten that, but here's a right triangle. Like literally somebody is doing a talk through here in the private chat. And that's what I do for a living, right? Is a talk through. I mean, literally just talking through like what the heck my thought process is on any of these problems. I mean, it's very, very not comfortable to do. Like nobody really likes talking about how they think about these things unless they're absolutely sure that they're right. And nobody really loves listening because it just seems like somebody else's like personal thoughts about math. But of course, that's all there is. Like all the real thing about this is I'm seeing much more in this private chat on the various steps and where you guys are. That's what's so important is each step that is correct. What happens to all of us is we do like 5 correct steps, then we get something we don't know, and then assume the whole thing is a disaster and just walk away. Whereas we just got to tweak it. So I am going to say the answer that I'm starting to get a lot, and there is an answer that I'm starting to get a lot in the chat that is right. Wait. Maybe, do I want to say it or not? Well, yeah. But no, I'm loving I'm literally laughing. I mean, because I can't keep up with what's going on in the private chat. And partly I can't do it justice because if each person in the private chat could see what everybody else is doing, they would see what a substantive discussion it actually is. But, okay, yes. All right. What time is it? 12:40. I don't know exactly. And I usually say like the deal is that we go on once I've gotten a right answer. I will say I have gotten, oh, yes. Yes. Okay. And oh my God. I don't know why this is so funny to me. All right. Because I feel bad also now, any private chat thing that's like left hanging that I didn't privately respond to, I kind of feel bad. It's kind of like homework or something, but yes, I now see the right answer. Like, oh, don't say that. Oh, don't say. Oh, okay. All right. No, something about this is productive enough. I'm going to shut up for if anybody's. It seems like some people are actually really are thinking enough that they don't want me to ruin anything, which I totally respect. I'm going to shut up for a couple more minutes. But if you are among those who think you have a final answer, or even if you think I've already said that it's right or something, one thing I'm going to ask is, what's really useful. The best way we could show this to each other. If you think you have a right answer, then please see if somewhere on your paper you have at least two clear, well, no, I would say at least three clear individual triangles. Like if you really, yeah, I think that is right. Yes, it is right. Person who just, yes, hold on. But yes. Um, uh, well, not quite. Wait, so I don't want to, I'm not going to say it yet. But I will say this, what you need to have on the piece of paper to really show yourself that you know what you're doing. And that's what the pictures are. I mean, this is the problem with when physics gets like this is people, part of the reason some people don't even know if their answer is right, like part of the reason people are asking me, and if you think about it, at a certain point, you can't, at a certain point, you know, when you're really doing science research, like there's nobody to ask, right? Like that's actually what we're trying to learn here is how you get to the, it's not really so much about having right answers. It's about actually even knowing how to know whether your answer is right or wrong without having another authority to go do blah, blah, blah. And how do you know? Well, one thing is the pictures. It's possible many of us are still at the stage with physics where the reason we don't know if our answer is right or not is we're still not totally entirely sure that we know what the question is. Like we do stuff that seems like it's right for what it is, but we don't know how it connects to the thing that's being asked or what. So I'm going to show you my pictures in a second. Ideally, they're your pictures, really. I will tell anybody who thinks they've gotten it right or thinks they're done, you really should have at least three clear, separate right triangles somewhere on your page. I mean, everybody should. This is the way to do it. So I'm saying to everybody. But if you're trying to go for like the extra point on the touchdown or whatever, really see if or if you were maybe flirting with the idea of sharing your work with everybody, which would be really helpful in a way, but is also makes people feel vulnerable. On your paper should be like at least three separate right triangles. And I'm going to show you what they are for me in a moment. But those right triangles, especially if you think you're getting, well, either very much if you think you're getting this or very much if you don't think you're getting this, every triangle you draw, and you should be drawing right triangles, each right triangle you draw should actually be made up not of three sides, but of three arrows. Like, and again, if you're not sure what's going on, you want to start getting in the habit of really drawing arrows and breaking up tilted arrows, treating tilted arrows as hypotenuses and adding legs to them to make them their own individual right triangles. That's what we're really doing here is making individual right triangles out of arrows. For those of you who think you already do know what's going on, or and maybe you do, please make sure that you're not just drawing raw geometric triangles on your paper, that you're not just drawing sides, but you're actually drawing arrows because the arrows carry the weight of this whole process, which is us actually trying to add up directionals, right? Like we all kind of know how to add up numbers. Here we're adding up directionals in two-dimensional space. It's the arrows that are really doing that for us. So I'm talking enough. I don't mean to be putting everybody in suspense, but a couple of people actually asked me very nicely, like, please don't say the answer yet. I'm still working. I totally respect that. And now all right, so I'm going to take one more minute just to try to catch up with this private chat. And then I'm going to go over it, but I'm going to go over it feeling a little dirty inside, I'm going to go over it feeling like maybe really it would be better if somebody else went over it besides me, but I'm going to stop confusion for a second. But let me just respond to this private chat for a moment. And again, obviously, with this stuff, if you put something in the private chat here with this whole discussion, obviously you could submit that for the points. I mean, again, I'd rather usually this be public, but this was quite. think, all right. Sorry. Oh, yes. We are going to start in a second, I think, but yes. Yes, yes. I'll be with her in a second. I'm also trying to. Oh, wow. Okay, cool. I'll see that. Okay, let me see. Okay. Ah, yes, yes, yes. Okay, now that's a very fair question. Okay, hold on. I'm going to answer one more. So this is, I'm going to answer one more question and then I'll be with everybody. But this is, and I'm sorry to, if hopefully people are thinking, but if they're sitting there waiting for me, I apologize. But again, I feel like I'm getting to know more people now. So hold on one second. Okay. All right. Wait. So okay. Before I get, I'm going to fall down. Oh, wait, okay. There's another one. Okay. Wow. This is, this kind of feels almost like lab. Okay. Well, okay. I'm just looking at another. Ah, ah, yes. Yeah. Okay. Hold on. I'm going to respond one more. Now I can't even, this is like, I can't even stop the education. It's so crazy. No, I'm going to answer this one more question because I'm getting better. It's so funny. I'm getting better and better questions. Like this is feeling more and more like a class, like every minute. Now, again, there's a point at which it would all just be better if this were all of us at the same time, public. So I don't know what to do about that. But so bear with me. But these questions, yeah, I feel like people are clear. You obviously are thinking very specifically about physics now. All of you, you're in the physics headspace, and that's what we're trying to do. So yes, hold on a second. Okay, yeah, I'm going to start doing this in a second. I will say now I know really anybody who's thinking at all and actually trying, first of all, is doing something right, and I know what they're doing, and is like now we're at a point where most people, if they need anything from me, like, and again, if you've already gotten the right answer, then then you can rest on your laurels for a second, I suppose, and also you can maybe like physics and do more. But anybody who thinks they were struggling at all with this really now has given me enough specific to work with, has admitted enough of what they do get that I think I can, then they'll see what's missing and be able to address it in a moment if it hasn't been addressed already. The thing that I really just have to keep saying to all of you, it's so fun. Physics is so personal. That's what's so weird about all this. Okay. I mean, it's the last thing you'd expect to be true of physics, but it is so, first of all, science is more personal than not science when you really get down to it. And physics is the most personal of the sciences because it's about you and your own brain all the time. Like I could get more into it, but physics is really about trying to think through the next step by admitting to yourself how weakly you feel about your thinking on the last step. That's always what it is. It's like this, you have to be honest with yourself of where you lose the thread, and then you always get more thread once you do. And that's what's happening in these chats. Okay, so I'm about to do it now. One thing I'm definitely seeing is the overall summary is I'm going to make an XY chart, and I'm going to show you all. I'm going to make a 2-column chart, 2 columns, because we're in 2-dimensional space. I'm going to make 1 column for the X and 1 column for the Y dimension. This is what I literally do in my own private notebook here, which I have. I'm not private like it's private, but I mean, like I don't have some faster way to do these problems than what I'm about to show you. And it involves always, for any 2-dimensional problem, a 2-column chart. If I were doing a 3-dimensional problem, I would have a 3-dimensional chart for real, and that often does happen. And then I'm going to have 3 rows in this chart. I'm going to have 3 rows because I'm going to have 1 row for each vector that we're being asked to add up here. The chart is how I add things up. And the belief is that I can only add things up in 1 dimension at a time. So I've got 1 column for each dimension, and I've got 1 row I'm about to have, as soon as I make this, 1 row for each vector. And you're going to see that actually the hardest vectors to work with are the ones that are the easiest to work with. Like you'll see that in a second. But each vector I'm going to turn into its own hypotenuse of its own right triangle. And then I'm going to tally up all the results of these 2 columns. And from the results of the 2 columns, make one humongous right triangle. And it's the hypotenuse of that I'm going to be looking for. I'm going to show everybody. But but what I want to say is I've gotten some diagrams from people, and I'm very tempted. Some really nice work, like in the chat, like as JPEGs or PDFs or whatever. And it's a very calculated risk on my part either way. Like I will be very honest. In the other class, I took one of the sheets that someone gave me, and I talked. It was beautiful, so we shared it with everybody, and I talked about it for a while. And I think it had certain major advantages that it wasn't my work, that it was someone else's. But I think it also had some disadvantage to do that. It might have made that person uncomfortable. and I'm not going to do it in this class today for this reason, that some of the drawings I've gotten are so beautiful and perfect and definitely better than what I would show anybody. But the one thing that they don't have is arrowheads in them. And I don't want to spend 15 minutes talking about someone's drawing and keep talking about something it's missing. So I do want to say to everybody, well, I'm about to draw this my way. The one thing that I'm encouraging, every time you see me put a tip on an arrow, like an arrow has a tip and a tail, that is realize that's a place where it's really easy to leave the tip off and think it's not important. But it isn't true. Like, what you want to look at your own diagrams, and anytime you see a triangle on your piece of paper, it should not be. You got to know that even on exams, I take off points for this. You can't have triangles just sitting there with raw sides. Each side has to point in a particular direction, and it's a test. It makes you make sure that the triangles are actually right, and it makes you know where your answers are and whether your answers are right, because you'll see when I draw this that the arrows can only go a certain way. There's rules for how the arrows go. And if they go the wrong way, then you know you've done something wrong. Or if you can't make them go a right way, you're doing. So the arrows are actually the calculational technique here that we're learning. So I'm going to ask I'm going to ask you to forgive me for not sharing the pictures that I'm getting. Like, I've gotten some 2-column charts that are awesome and perfect. The numbers in them are perfect, but how we would know to do the positive or negative signs gets tricky without the arrowhead. So I'm not sharing. So rather than whatever, I'm going to share mine. But no, yes, people have definitely got the right answer. And I guess I should say at this point, I do think the total answer to the whole thing, well, we're looking for a total answer. That means a total displacement. That means we're looking for how far by magnitude. Yeah, I mean, in the end, I'm going to draw this again, but I got a good question about this also in the private chat. When I say I'm looking for magnitude, I mean, let me back up. I'm looking for a displacement vector. I'm asking everybody to add up 3 displacement vectors and get one big one. And any vector has a size and a direction. Like, any vector can be represented by an arrow that has some size and is pointing in some direction. When I say the size, we call magnitude, and the direction we denote with an angle. So the final answer I'm looking for, when I say it has a magnitude and I want it, what I mean is I'm looking for, if we did these 3 actions, if we walked these 3 ways, how far did we walk at the end of the day? Here, this picture, like, this doesn't give anything away, this picture. This just is the question, in effect. But here, like, if I first walked 10 meters north, and then I'll make it better. Hold on a second. If I walked 10 meters north, and then from the tip, I walked 20 meters southeast. So something like this, 20 meters at 30 degrees. Yeah, something like this, something like that. And then from its tip, I walked 30 meters, but at a very large angle of northeast, right? So I did something like this. What we're looking for, like, this is a diagram of the whole situation. What we are looking for here is this vector, the vector that takes us from the original tail to the final tip, the vector that represents how far we were displaced. This is supposed to be an arrowhead. How far we were displaced and in what direction from our initial position to our final position. So notice even just this crude diagram, and this is just a crude diagram that represents the situation, but it is composed of 3 arrows placed tip to tail. What we're gonna do is we're gonna say, sorry. And so when I ask for that final vector, when I say what's the answer, by that I mean what's the length of this whole final vector? Call that d for distance. In other words, the magnitude of that displacement vector is what we mean by distance. Distance equals magnitude of displacement. It's just the size. So I'm going to want the size of that vector, but I'm also going to want its direction. It's not due north, it's not due east, it's some angle. It's some angle, it's some amount, if I draw things correctly, some amount north above, it's some amount north of east if I've drawn my diagram up remotely to scale. Or if my diagram worked out a different way, maybe that angle would point southeast or something. But it looks like it points northeast. I just don't know how much, and there's no way of guessing. So I'm literally looking for, when I say I'm looking for magnitude, I mean, I'm looking for the overall distance, the size of this final vector. And when I say I'm looking for direction, I mean the direction in which that final vector is pointing. Now, how am I going to get it? How am I going to get it is these steps that some people were putting in the private chat as totally correct steps, but they just didn't quite know how they fit in or what to do with them. The steps are to get 3 rows to add up in this XY chart. Like what we are doing an addition problem here. We're adding this vector plus this vector plus this vector. Each one of those vectors is going to be a row in this chart. Why is it in a chart? Because each one of those vectors sends us somewhat to the east or west, and independently yet simultaneously somewhat to the north or south. The number, if I look at that first vector, the first vector sends me, let's change the colors. That first vector sends me nowhere east or west. It sends me 100% all 10 meters north, right? Because that vector happened, we were told, I just walked 10 meters due north. Then the next vector, okay, the next vector is this 20 meters to the southeast. That's somewhat south, somewhat east. How much each? That's what I need to know for the chart. How I find that out, I personally would zoom in on that next vector. I'm going to zoom in on every single vector. This is why I say you're going to have at least 3 triangles on your piece of paper. I zoom in on every single individual vector and make it the hypotenuse of a triangle, unless it doesn't look like I can, in which case I don't need to. But here's the next vector. So I'm going to do it on the next page. Sorry. So this one's 20 meters long, and it was at 30 degrees. Now notice, 30 degrees southeast, it was called, I was told. This vector in and of itself is just a vector. It's just a representation of me walking 20 meters at a certain direction that we call 30 degrees southeast. Like you notice that angle is just being drawn a certain amount south of an imaginary east. Like it has nothing to do with the last vector. It only has to do with a horizontal reference line. So this second vector, if I zoom in on it, when I say to zoom in on it, I mean to recognize that to go 20 meters southeast is to go some amount east, and it's equivalent to going some amount east and then going some amount south. Oh yes, this is really where I want to pause. This is the part where I do something that a lot of students don't do at first, especially students that are getting things right often will not do this at first, and then it really messes them up later. Not to be critical. I'm saying, let's really zoom in. I'm saying if something goes southeast, southeast is the sum of south plus east. It's also the sum of east plus south, because addition is commutative. And that is, in fact, the better way to look at it. Like to go some amount southeast is equivalent, to go some amount southeast, 30 degrees, brings you to the same place that going a certain amount east and then going a certain amount south would bring you, right? And I'm specifically saying, I'm saying that eastward pointing vector plus the southward pointing vector equals the southeastern pointing vector. And there's a consistency to that. Notice I'm not saying southeast plus south equals east. Like the 2 vectors where their tips meet, that's not addition. Tip plus tail is addition. So this side is 20 cos 30. Okay, so as a triangle, those sides are all correct. 20 cos 30, and 20 sine 30. If I just leave it as a triangle, then those are just numbers. But if I was doing this in order to put into my XY chart, this whole thing is row, the whole thing is row number 2 of XY chart Um, remember, row number 1 brought us nowhere east or west and brought us 10 to the north. And I specifically mean 10, like positive 10, because it was 10 to the north. This vector evidently brings us 20 cosine 30 to the east. Now that's a number. That's like 0.877, like on your calculator, if you're in degree mode, cosine of 30 is like 0.877 multiplied by 20, and you get like 17.3 or so. And that is, but if I look at that arrow, that is 17, the size of that triangle side is 17.3. But if I look at the arrow, it's specifically saying 17.3 meters east. So I know to put positive 17.3 meters as an entry. That's a positive right there for the second vector. However, it's at the same time, it's bringing me 20 sine of 30 degrees down, south. The size of the triangle side is just 10, like triangle sides have to be positive numbers. But what is going to go into this column here is negative 10, negative 10. Why? Because the arrow is pointing south. Like, right, I mean, this is all about directions in the end. So if I'm drawing the triangle faithfully, and if I'm just following one step at a time, the triangle, I was told to draw it south because the original vector is southeast. So this thing is pointing south. So it becomes a negative 10 in this tallying up column thing. Again, this was positive. And now, so a couple people in the chat, like totally, a number of people actually, totally knew from last time or knew somewhere in their brain to break up triangles like that, to break up vectors into components. Well, they might not have known, but so you do the exact same thing for the next one now too. Like the next one is 30 at 60 degrees northeast. So the next one's like this. It's even longer. And this angle is given at 60. All right, so this, again, I have to envision this right triangle here. Like the right triangle doesn't form. What people always want to believe that if they draw the vectors down, they unconsciously, especially if they're panicked or if they haven't practiced, what happens is people draw the vectors and they know enough that right triangles are involved that they think somehow the vectors drawn together will make right triangles. And sometimes by coincidence they do. But then that's what messes everybody up. That's not what we're looking for. We're looking for each individual vector to be its own right triangle, its own sum of some amount x with some amount y. And I always say the x first because we always want ultimately to measure and draw these angles with reference to the horizontal. So I'm always saying horizontal first. You'll see again what I mean in a moment. But like this 30 meters northeast is some amount east. It's some amount east. That's a number on the calculator, right? Plus some amount north, right? That's a number on the calculator. And so if I do these on the calculator, I'll get like 15 here, and it's positive because it's going to the east. And I'll get in the y column, I'll get like 0.866 times 3, so that's like should be like 26, yeah, like 26. And again, I'm chopping off digits, but there's no way not to. These are irrational numbers. We should be somewhat consistent with significant figures, but no matter what, we're all getting approximate yet precise and yet accurate numbers. So far, what I've definitely done, so far I'm saying you cannot do this problem really if you're analytically doing it, if you're not just drawing, I shouldn't say just, but besides drawing and measuring, if you're analytically doing this, you have to break up that second vector into 2 components, and you have to break up the third vector into components. And a lot of people did that, but if you don't quite, and that's great, if one doesn't quite know what to do with those components once they've broken up, it's partly because you might not see that even the very first vector itself has 2 components. It's just one of the components is so kind of easy in a way that it doesn't even seem like a component. Like that first vector has an x component of 0. Once you see that, and that doesn't take any triangles to do, but once you see that we're just getting components for hopefully, for each of these vectors, and we're going to add up all these numbers now. Some of the numbers are negative because of the way things point, but then we're adding up all the numbers because this is an addition problem, because we were asked, what's the total displacement of everything? So when you add all these up, when you just, because we know how numbers add, we'll get 32.3 in the x positive, and 10 plus negative 10 is 0, but 26 positive 0. I'm just changing the Okay, so these are definitively positive numbers, not because they have to be, but because the numbers actually add up to positive numbers. And then the final thing is, what do I do with that? Or where's my final answer in all this? And a couple of people did very reasonably and helpfully ask me in the private chat, like, what does it mean that you, Yaverbaum, are asking for magnitude of final answer? Like, what does that even mean in the picture? And it's true, you can't even see. When I'm asking for the magnitude of the final answer, I'm asking for the length of the final hypotenuse, the hypotenuse that takes us all the way from the beginning to the end of all this. Well, I don't exactly know what that is until I've done all this work out. But what I'm saying is, at the end of the day, if I started somewhere and I went north and then I went southeast and then I went northeast in this fashion, then what we're saying is, at the end of the day, whoop, I don't know what just happened there. Sorry. Okay, at the end of the day, right, like the key thing I'm saying, I'll go back to the page in a second. I'm saying, in principle, to add three vectors, you first need to make three right triangles, three separate right triangles. The first one you can't really make. It's really a triangle with legs of 0 and 10, and therefore hypotenuse of 10. So whatever you can't quite make a triangle, it's because you don't need to, because things are that straightforward. But technically speaking, or in principle, we had three vectors. We made three separate right triangles, got three separate sets of components, three separate sets of legs for those three separate vectors. Add them all up, get a total. That means we now have a total x and a total y. Well, that's what is the total. Like, at the end of the day, by going nowhere and then going a certain amount to the east and then another certain amount east, we went a total amount east. How much total? 32.3 meters. Like, this is where the whole point of the column is, that then we take the two answers, the two sums from the columns, and they are two independent motions that have now accumulated, the x motion and the y motion. So we put them together in one big mama right triangle. Like, and this is the method every time. Again, like, for as many vectors as you're adding, whatever kind they are, each one you make into its own right triangle. So you break everything apart into smaller pieces. You add the smaller pieces all together in piles, pieces for x, pieces for y. And then you put back those pieces together in one big mama triangle like this and say, oh, I get it. At the end of the day, then, what what we did was, oh, I see, the vector that we're looking for, the final vector whose final magnitude and direction is what we've been asked for since the beginning of this problem, is right here in the picture. Like, this is what we're looking for. And this is what we're looking for, right? So this is where I think a lot of people put in the chat, even pretty early. In fact, some people put, I believe it was like 41. Yeah, like 41 point. I can't even remember now. But see, it is all about this XY chart. The answers of the XY chart at the end are the two legs of the final triangle that you're always solving for in the end. You're solving for a magnitude and direction. I think we get. Oh, no. Right. And the answer, so the answer is 41.7 meters. Sorry, that's meters. Approximately 41, like approximately, but not meaning I'm throwing it away, not meaning random guess, meaning we had to chop off digits because there's irrational numbers involved here. And we'd rather say numbers that we could picture on a meter stick than in a square root or in math class or something. So the final answer is like approximately 41.7 meters. Oh, in what direction? Like north? Well, not quite north. East? Not quite east. Northeast? Well, not exactly northeast, because northeast would be like literally 45 degrees northeast, but we got approximately 38.8 degrees northeast. And again, I know it's northeast because this final triangle I'm drawing that all came from the XY chart, this final triangle is made up of east plus north. So the angle here is where I want it to be and what I want it to mean. That angle between the tails is a northeasterly angle. Again, I could have done all the steps right. I could have done all the steps right, everything right, but then just kept, well, yeah, let me just, so this is the answer. Sorry. The answer is 38.8 degrees, or you might have gotten like 39 or 37, from rounding. But if you got like 48, then that's different, right? And then that might mean you just made one little mistake in your method, or you might have done something completely wrong. But this is 38.8 degrees northeast. That has to be part of the final answer. And what I just want to, I know we have like 8 minutes, not, and I think people are doing great. But I get very defensive about this thing. I just have to show you that, like, if in the end, if I don't keep the arrowheads and the tips and the tails, and if I just don't practice on my own, if I just like hear this and I'm like, oh, that makes sense, I get it, which is fair. But remember, whenever you just hear something, that's like watching someone play the piano and being like, oh yeah, that sounds nice, that's great. But that doesn't mean you can play. So what I'm saying is you could do all the numbers correctly, but if you leave off the arrowheads and the tips and the tails, and you get down to a final XY chart and you're like, and you do all this right, and then you get down to the end and you get like 32.3 and 26.0, just like I got, right? So all this could be right. But then you draw a big triangle and you're like, okay, that's fine. I'll do 26 and 32. Like, this isn't even wrong. You could say 26 is my Y and 32, or even better. If you don't put arrowheads, you could be like, this happens all the time on exams, and and it's really frustrating to the people when this happens, because it all seems like it makes sense to them, and then it's often argued they can't see why something's wrong. But if you do this, you do everything right, and you end up with 32 in your horizontal and 26 in your vertical, right? And then you're like, here's my triangle, and here's a right triangle. So I'm solving for this. You can even use the Pythagorean theorem and get that side correct. But then when it comes to the angle, then what will happen is if you don't have any arrowheads here, you know you're solving for that Pythagorean distance and you'll get it right. But you also need an angle. You need a direction of northeast or southwest or whatever. And what will happen if you don't have any arrowheads, first thing that occurs to people is which angle do I actually want? Like, what's Yaverbaum looking for? Which is the angle to solve for? And it's a really good question because neither of those angles really does look like it makes much sense. Like, we're trying to find the angle that actually represented what we actually did. And those angles actually end up looking sort of wrong. In fact, you might even solve for this one because it seems more right. And if you take this seriously, this angle looks like a northwest angle. And that's not right. Like, you couldn't have ended up northwest if you did all that north and all that east stuff. But this triangle makes it seem that way because it just puts a vertical together with a horizontal with no tips or tails. Though the vertical and the horizontal do not go together like that. They go together like this, which makes actually a different triangle. Like, I'm saying the correct triangle looks like this. And without arrowheads, you could easily end up with this triangle, which is wrong. Like, none of the angles actually make sense here. Or you could even end up, I've never actually said this before, but the horrible thing is you could be like a really good student and follow all this and do all the math perfectly. But if you don't get that it's actually physics, sorry, and you don't keep the arrowheads in, the other thing that could happen is you can get to this final step, 32, 26, 0, and you could literally put in, okay, here's 26, here's 32, and they even sort of look tip to tail somehow or something. Is that what it, or sorry, you could even do like this. I mean, you could even go like this. See, there's so many different triangles you could, this is what I'm really saying is I'm even panicking right now there's so many wrong ways to do this and only one right way to do it actually. But they don't know, they all seem the same until you try it yourself. If you get 26 at the end and 32 at the end, you might well say, okay, 26 in the Y component, 32 in the X, and say this is your triangle right there. And even that seems very right. Like 26 went up, 32 went over. What's the problem? But the problem is here too. Which angle do you solve for? This one seems kind of okay because it's like, I guess I went that way. It kind of looks northeast. Like, and if you look at any other pictures, it seems like your answer should be northeast. That angle will even seem okay, but if you punch that into the calculator and do SOHCAHTOA, you'll get the wrong answer. It will, instead of saying 38, it'll say something like 52, because this angle right here that I'm talking about is being measured from the vertical, not from the horizontal. It's not actually, this thing here is not a northeast angle. This is an east-north angle. It's the complement. And I'm not inventing that technicality to mess you up. I'm saying to avoid that mess up, I'm saying one last time, you make an XY chart to tally up all these components of whatever kind of vectors you're talking about. But understand that that everything, if it's positive, it goes one way, and if it's negative, it goes another way. And by goes, I mean put arrowheads. So at the end of the day, notice what I did. Well, I'll draw it one more time. At the end of my chart, like my chart said something like this. What was it? So this was my chart. The final step of the whole problem, once you get a chart, is you literally turn it into a literal vector triangle where you take seriously, like you always draw the X first. So I draw X is positive. It goes to the right. If that had been negative, I would draw it to the left. And I know I just said this before, but this is the part that everybody always, it just is worth the emphasis. I'm adding tip to tail. I do a tip that goes to the right, and then from the tip, I start a tail of something that goes up. So I have this and this. And the answer I'm looking for is this dotted arrow and this angle. And then the angle I get, I mean, I almost wish I could do one more example right now with negatives just so you could see, but the angle I get between those two tails, even if the proper answer to the final thing looked like that, then the answer would be over here. The answer I get between the two, well, okay, I'll write this as the last thing. I'm saying, if you do this right, Is that 1:30? All right, this is the last thing I'm writing. We're going to go. I thought it was, okay, yeah. What I'm saying is you'll really know you've done all this right, and it can get complicated. But once you've made an XY chart, and I always do, it's not a trick for like, it's not a baby step thing. It's like the way to think about it. I mean, you could draw it with columns rather than, I mean, you could draw it with commas rather than columns, but you somehow have to separate X information from Y information. And you'll know you've done it right. And this is the last thing I'll say. You'll know you've done it right if by the time you get to a final triangle that's made up of the total result of all the X stuff with the total result of all the Y stuff, if the angle between the two tails of between two tails, and there will be such a thing in that triangle, if two tails meet at an angle which is measured from the horizontal, you'll know you've done it right. That's the consistency check that you want at the end. If the angle that you're looking for, the angle between the two tails, is in fact being measured from the horizontal, then that means whatever number you read there, like 37.8, would be 37.8 north of east or south of west. It will be a normal angle that everybody can relate to. If your final angle between the tails is measured from the vertical, then something about your whole triangle has gone cockamamie earlier on, and some numbers therefore really could actually be wrong. Like it means something got messed up in negative signs. So the arrowheads keep track of the negative signs, and the negative signs, if they go wrong, they can actually make the numbers go wrong because it's addition or subtraction. But people rock this. A lot of you clearly did rock this, and I think that even people that didn't get, even if you didn't, anybody who got anything with this and put things in the chat really should commend themselves and feel like they're making some progress, because I think they are. I know it's 1:30. I'm totally going to go, but do submit whatever you put here. Put it in the blah 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 and blah blah. And we'll talk. Oh good. Oh good. Oh, I'm glad. Oh, thank you. No, that's really nice. I just heard some nice things. That's awesome. Then I really should shut up. That's goodbye, everybody. I'll post all this. I will post.